So we are doing question 4, part A, part 3. So we said A, part 3. The limit as x plus 2 of the root of x squared minus 4 over the root comes down over x squared plus 5x minus 14. So here we're factorizing the numerator. We've got the root of x minus 2, the root of x plus 2, and then we factorize the down part. We got x minus 2 and x plus 7. So that this part and this part cancel. Then the remaining pieces we substitute 2 while we get. We substitute 2 while we get. So we get the root of 4 over 9, which is 2 over 10. So the limit questions, you just need to, when it's going to infinite, so by factorizing the highest power in the denominator, when it goes to constants, just check what's making the denominator 0, do the factorization around. If nothing is affected, just substitute the numbers on the out. So let's go to B. B says, evaluate. This means integrate. So, the main way to write this expression, 2x, instead of saying root x, you write it as x half minus, instead of saying 1 over root x, you write it as x minus half. Yes. And from there, you put this together, we have 2x with the 1 here. So 1 plus half. Remember, you add the powers with the bases are the same. So you get 3 over 2 there. And then minus x minus 1 over 2. So now we can now integrate. So we say 2x. So we have 3 over 2 plus 1 divided by the 3 over 2 plus 1. So we integrate. There where we are dropping the power. Now here we are adding the 1 to the power. And then minus x minus 1 over 2 plus 1 and divide by minus 1 over 2 plus 1, then plus a constant c. So when you add 3 over 2 plus 1, you get 5 over 2. So we have 2x 5 over 2 over 5 over 3 minus x over half c. So you may write it as 4 over 5 x 5 over 2 minus 2 x half plus c. So that's the incremental part will just protect them in the numerator area so that the thing looks good. And this becomes the final thing. So to integrate, Remember, we don't need much product, so where possible, you can get rid of the product. Okay. Um, we move to the last part two. The part two says using a suitable substitution, evaluate this guy. So the integral of x squared and the root of 1 minus x, yes. So you let u be 1 minus x, 1 inside the root, and then differentiate u. You get negative 1 multiplied by x. So you let u be divided in the root, and then you differentiate it. Again, we want to change from x variable to u variable. So you go back again to the left new part and make x a subject. So you have x is equal to 1 minus u. We move x to the left and u to the right. So now you go back to the question where there is x, you substitute 1 minus u, and your x is squared. And where there is 1 minus u, I mean 1 minus x, you say with 3 equal to u. So we have u now the power half. U, we said the x is minus 3u, so this part is 3u, and the minus can be taken out something. So now we have the minus. So we do the expansion, so it should be 1 minus 2u plus u squared. Then you expand, and then you have. So you all know how to expand 1 minus u power 3. That's how it will come out. And then we have minus 1 times u half, we get u half minus 2u times u half, that is the 2 u 3 over 2, and then plus u 2 times half is just 1. So we just get to this u. And then now we integrate. So we have minus u, they have to add the 1, it will be 3 over 2 over 3 over 2 minus 2 u, we add the 1, it's 5 over 2 over 5 over 2 plus u squared over 2 plus c. Then you go back. What was your u? Whatever there is u, it's back. What was the what is minus 1 minus x, that is u, 3 over 2 over 3 over minus 2, 1 minus x, 5 over 2 over 5 over plus 1 minus x squared over 3 plus 6. So in integration, we don't have Go back to me. What we have is substitution, where you change the variable, the different variable. Now when you change, you also change on the dx part. You make it be in the form of the new variable. Yeah, you can get it. Okay. Next, we go to, if you have some more questions. This is the fields written down in first. So you see, uh, let's go to part 4C. Part 4C says, sketch a graph sketch a graph so sketch a graph of sketch a graph of the following function and determine if it is continuous at x is equal to -1. So let's start by sketching the graph. Sketch, you start by writing the number which is there. So we're doing everything at -1. So you substitute -1 in the top function. You will get -2, -1, -3. This equals to 2 minus 3, which is equal to -1. So we'll have -1, comma -1, not included there. And then pick a number that is less than -1. Let's pick -2. Then we have -2, -2, -3. That's 4 minus 3, which is 1. So we get -2 comma 1. The idea is you don't know whether it's going up or it's going down. So it's going in this direction. Of course, if we wanted to find this, we would find it by getting -2x to 0. And -2x minus 3 to 0, which is -3 over 2. Then we are told that when x is equal to -1 here, the function is -1, meaning we come back and close here. Then now, when x is bigger than -1, you substitute in here, instead by substituting -1, you get -1 squared -3. That would be 1 minus 2, which is -1. So you can start from there. And then let's see when x is 0, you get -2. So when x is 0, we'll get -2. So we'll have a curve. That's a quadratic. uh, of this time. It's crossing on x, it's crossing at substitute here. You're putting x squared minus 2 to 0, and you realize that x is equal to plus or minus 15. And we only see the root here. So this is the graph. We want to check if it's continuous at x is equal to -1. Of course, the eyes can tell that it's continuous, but you need to solve. But to be sure that it's continuous, the best thing you do is you substitute -1 in the function. You substitute -1 in the function, and we are told that when you do that, you get a -1. The second thing is you find the limit as x goes to -1 from left. So from left, you use the function that is there up. This is give us -1. You also find the limit as x goes to -1 from right. We substitute where it's say greater. So in x squared minus 2, again we get -1. So then the two side limits are equal. This means that the limit of x goes to -1 of f is actually equal to -1. So the limit exists. Then we compare now on the third part. We want to say the limit as this guy y for f is equal to -1, which is our f of -1. What does it mean? It means that f is continuous. That's pretty good here. See, not a big deal as such.
Sir, can you explain on the expression of the this one x squared minus 2 when sketching, which is making a curve?
What's the quadratic limit?
Yes. Can you explain on how it's forming the quadratic?
So when you're sketching a quadratic, remember what you need: the turning point and the intercept. So because when x is 0, you find the y-intercept. So when x is 0, you get -3. That's why that's the y at -3. And then the x-intercept, you repeat x squared minus 2 to 0. You get x is equal to plus or minus 3. Now we are on the right of the graph. So you write only root 2. Because the left part where you find -2, it has been cut off. You only want to state where x is bigger than -1. And then from there, it's a curve. So just draw a curve and not a line. X squared is a curve.
All right.
Okay. Then we can go and check. So if you check question 4, part 1, nothing is challenging here. Find the limit as x goes to -1. So when x goes to -1, Again, here you can't go direct, so you have to factorize. So you factorize x squared minus 1, and the denominator and something will cancel. And then you work out stance. Then B1, B2, and B3. So there I use the idea of a graph. If you ask to pick the value of x of minus 1 from the left and from the right, which one do I talk about here? I'm going to give an example of this kind. That's just factorial reduce from down, then cancels, then cross multiply and find here. First the triangle. The application question. So you could have, so this was for us, of course. So we could have this question in the kind of question. So you can get much of your application during the question. We don't go so wide. The other inequality is that's it. I will know you. We can factorize. And this is like after you're gonna break minus 3 is less than 6. And then you make out that. Not this way. Let's go here. Okay, so let's see how to graph. With another one here to the graph. So now, so the graph now. So we go to x is equal to 1. And substitute 1 in the top part. You get 2 times 1 plus 3, which is equal to 5. So 1 comma 5. We open and go to the next. So when x is 0, we get 3. So it means that the line goes like that. Of course, 2 is minus 3 over 2. If you get 2x plus 3 is 0. And then when x is equal to 1, we're getting a 4. Yeah. According to the definition of the function, when x is bigger than 1, we are starting from 5. Because you substitute in here. So we get a 5. It's also close there. I mean, we don't close. We just start from there. Then we pick a number bigger than 1, say 2. So you have 2 squared, which is 4 plus 4, giving us 8. So that's telling us that we move going up. And it's a curve. So this curve will be like how line. Like that. Then we are supposed to check continuity at 1. So f of 1 is equal to 4. The limit as x goes to 1 from left. So from left, we are using x plus 3, that's 2 plus 3, which is 5. Also, the limit of x goes to 1 from right. So from right, we are using the down part, which is x squared plus 4. So we have 1 plus 4, which is 5. So you see, the limit of x goes to 1 plus of f of x is equal to 5. But the challenge is that on the comparison part, this is not equal to f of 1, since f of 1 is 4. We are having 5 not equal to 4, and so this means that f is not continuous. X is equal to 1. And because of this, we can play. So for the quadratic guy, you just want to show that it's not a straight line. So just trying to demonstrate that it's not a straight line. You didn't say, so then show that it's turning there, it's not turning there, it's supposed to turn at 4. So you're just trying to differentiate between a straight line and a curve. Yeah. So this paper was just trying to help us revise some more topics like binomial, like limits here, like when it is continuous, like the inequalities, it's in continuity, limits, binomial, inequality. And also the test was also helping us to revise integration here, the limits, differentiation here, binomial here, some inequalities, some polynomials here, and some expression of the domain of the root function. But you know, the coverage of the test also has trigonometry, which is not covered here. So we also want to look at three concepts. Much of it we're interested much in. There is some kind of how to sketch the graph of trig. We also want to check if you know the angles, and special angles, especially if you know one or two identities. Not spend much time there. Just to orient yourself so that in case you bring something close to where you are oriented, you are able to work out things here. So I think this is where it's just going to end. Let's use the day well. Maybe you're not in the day. I may answer questions when we post on WhatsApp. Most are active. You can answer some. Have a good day. The video is uploaded. There you go. Bye-bye.